Mechanization is something we mostly associate with the Industrial Revolution. But the Industrial Revolution could not have started without the early beginnings of mechanization throughout the 16 and 1700s. One of the biggest mechanizations that had an impact during this era was the mechanization of firearms. As countries became richer, they were able to afford more complex and reliable weapons. Eventually, the mechanic system known as the flintlock would become the standard infantry weapon throughout Europe. The system that would precede the flintlock was known as the matchlock, first introduced en masse on the arquebus. Arquebuses could be found all across the world, from the colonies of the New World to the steppe plains of Ukraine, and even all the way in Japan. The matchlock musket used quite a simple concept to fire. First, of course, there was the barrel that was filled with the charge and musket ball. There was a pan with a priming gunpowder on it, and by pulling a lever or trigger, one would lower a slow match onto the priming pan, igniting the gunpowder and firing the gun. The weapon had some unfortunate downsides. Most of this comes down to the slow match used. You had to keep the slow match burning for the gun to work. This made fighting in the rain extremely difficult, and fighting in any weather that could put out the match became a chore. The constantly burning match also meant that using matchlocks around any open gunpowder became extremely dangerous. This meant that matchlock muskets could never really be ready to fire if used around artillery crews. Even after the development of the system that eventually replaced matchlocks, they stuck around due to the fact that they were extremely cheap to make. A small sidetrack in the development of firearms was the wheel lock. This used friction of a wheel inside a mechanism to set off a charge and fire the gun. This addressed most of the flaws of the matchlock, but had some massive glaring faults. One is that the wheel mechanism would commonly fail, meaning the soldier really had to know how to take good care of their weapon. Compounding that problem was the fact that they were incredibly expensive to make. This meant that the wheel lock really only ever caught on in specialty roles and not as a general combat weapon. The final evolution of the muskets of this era comes in the flintlock. A few early versions of the flintlock could be found around Europe in the late 1500s, known as snaphaunches. These were mostly used in the Netherlands and northern Germany. Eventually, this evolved into the mechanism that worked well enough for mass adoption. The flintlock worked by using a spring-loaded hammer to hold a flint, and when the trigger is pulled, the flint would hit a piece of metal, causing a spark and setting off the gun. The main disadvantage was that it did require more work to make than a matchlock, which simply used a lever. But it did not cost nearly as much as a wheel lock to manufacture, meaning that whole armies could be armed with flintlock muskets, and by the 1700s, flintlocks were essentially universal in Europe. One of the flintlock's main advantages was that it could be easily put on safety. By half-cocking the mechanism or putting a piece of leather in the mechanism, the flintlock could be reliably put on safety but still be ready to fire. This resolved the problem of guarding artillery. Also, as long as the powder was dry, you could fire your weapon. One final thing to note about the flintlock is that by the time they became mass-produced, armies had become very good at standardizing how they were made. This can be seen in the consistency of the weapons in the army of William III. This means that flintlocks from the same manufacturers were almost identical. These improvements also led to the mass production of socket bayonets, which could be fitted on almost every barrel. This finally ended the era of pike and shot by allowing soldiers essentially to use muskets to fill the same role as pikes did.